All right, hi everybody. We're working through the Math 31 limits review. This is question 1M. Take the limit as x approaches 0 of this rational expression here. Let's plug in 0 here. So 0 over, well, okay, 1 plus 0 is 1, 1 minus 0 is 1, so this becomes root 1 minus root 1. Okay, so this is giving us 0 over 0 when I plug that in. So this is an indeterminate form. So I got a little bit of work to do, and I'm going to give myself a little bit of room. I'm going to start a little bit further to the left than I normally do. So this will be the limit as x approaches 0 of x over, okay, root 1 plus x minus root 1 minus x. Now, I think it should be pretty clear that what I need to do is rationalize that denominator, which means multiplying by, in the denominator, root 1 plus x plus root 1 minus x. So then it's the same thing in the numerator, plus root 1 minus x. Now, we should have seen in a previous question here, if you've been following this through here, that it's not really all that smart for us to multiply or distribute that through in that numerator. I'm just going to leave it looking like this. X times the square root of 1 plus x plus the square root of 1 minus x. I'm just going to leave it like that. Let's just investigate what happens in the denominator. Since these are a difference of squares, okay, I'm going to get the square of the first term minus the square of the second term, which will be 1 plus x minus 1 minus x. Now I'm still not taking the limit. I'm not evaluating that yet, so I'm going to leave that as the limit as x approaches 0 of x over root 1 plus x plus root 1 minus x. Now what happened in the denominator here? Well, I'm going to get 1 minus 1. So that's going to go away. And I'm going to get x minus negative x. Now that's going to be minus negative x is plus x. So this is going to end up being 2x in the denominator. So again, I'm still going to write this out as x approaches 0. But the x's are going to cancel, that x and that x. And so I'm going to be left with the square root of 1 plus x plus the square root of 1 minus x all over 2. And that is true so long as x is not allowed to equal 0. Okay, because again, 0 over 0 would be undefined. So that expression is equal to this expression as long as I include that restriction. Okay, so that's fine. So now, but we're not going to hit 0. We're only going to approach 0. So 1 plus 0 is 1. 1 minus 0 is 1. Square root of 1 plus the square root of 1 is 2. 2 over 2 is 1. So it turns out in this case here, the limit, maybe we'll go right up to the top here because I got no place else to put it. But the answer is that the limit is 1.